This is CPE 133. This is experiment 7. What we're going to do in this experiment is design a 5-bit adder-subtractor unit with a validity check. So objectives in this experiment are simply more experience with block level design. This is yet another non-trivial design, another design that uses sign arithmetic, which means it considers the input values to be signed numbers. As you know, signed numbers we represent using 2's complement. Additionally, the hardware just does what you tell it to do, like adds or subtracts, but the answer may not necessarily be valid based on the width of the data. So we also have to put in a validity checker in this experiment. So part of the objectives here is to understand the validity of your results, and you have to simulate this as well as put it on the board. And this will be more experience with the simulator. So once again, 5-bit adder subtractor with validity check considers the input signed numbers. You have to test it both visually on the board and simulate the results. Lots of provided modules that you can use in this design. It's mostly a block level design. There's like little or no extra logic you need to put in there. It's mostly the modules. There may be some logic depending on how you do your design. There's different ways to do this design, but it's primarily using predefined modules. Once again, you can test it on the board and test it in the simulator, which means you have to write a test bench. And there is a special case that we have to deal with when we're using signed numbers, addition and subtraction, but we actually skip that case. You don't need to test for that special case. It's listed in the text what that case is. I don't want to go over it now. And in the end, you essentially have to, in your test bench, show some valid results and some non-valid results, of course. And by all means, be sure to annotate your timing diagram. This is a typical design. We're going to design on paper first. Don't try to design it by typing text into a Verilog text editor. Define your modules, connect them up with the data and control paths, and by all means, when you have a design and you're not sure what to do, pass it by me and I can give you hints and tell you if it's going to work, tell you what it's missing. Additionally, you don't want to reinvent the wheel on anything in this design. There's lots of modules provided, and use those. And there are a few other notes in the lab manual. Be sure to check those out also.